All right, kiddos, welcome back. And we're going to begin our last topic in unit number 4. We're going to talk about something called stoichiometry today, and probably on our next video. We're going to apply a couple of the things we've learned in this video. Number 1, the mole concept, and number 2, balancing equations. Of course, now balancing equations relates to the law of conservation of mass. I think you'll find this interesting and sort of kind of fun to do. The math is not too horribly difficult. We're going to multiply or we're going to divide, and we're going to use the mole concept like I said. So all of these things you've already done this year. It's just a neat application of some of those things already learned. So we're going to study quantitative relationships between the amounts of reactants used and the amounts of products that are formed. That's called stoichiometry. Like I said, it's based on the law of conservation of mass. Recall, the law states that matter is neither created nor destroyed in a chemical reaction. In any chemical reaction, the amount of matter present at the end of the reaction is identical to the amount of matter present at the beginning. Therefore, the mass of the reactants equals the mass of products. That's a fundamental concept, kiddos, that you should already understand. All right, so the best way to teach stoichiometry is sort of just diving right in and working a couple of problems. So we need to start with a balanced equation. So remember, whenever you do a stoichiometry problem, please make sure that your equation is balanced. I'll remind you of that several times in class. I like to say that stoichiometry is the mathematics of a balanced chemical equation. So let's take a look at this equation here. If I put a 2 in front of Fe2O3 and a 3 in front of O2 and a 4 in front of Fe, you can see that that equation balances quite nicely. It's a 4 to 3 to 2 mole ratio. The coefficients represent the mole ratio, as I just said. So for every 4 moles of iron that I'd like to react, I have to have 3 moles of oxygen. And when 4 moles of iron react with 3 moles of oxygen, I will produce 2 moles of iron 3 oxide. So let's play around with this a little bit. What if I had 4 moles of iron and unlimited oxygen? How much product, Fe2O3, could I produce? Well, that's pretty easy. It tells us right here that for 4 moles of iron, I produce 2 moles of Fe2O3. So the answer is 4 moles of iron to 2 moles of Fe2O3. What if I had 6 moles now of oxygen and unlimited iron this time? How much Fe2O3 could be produced? Well, let's take a look. 6 moles of oxygen. If we take a look here, it says I need 3 moles of oxygen to produce 2 moles of Fe2O3. So what if I had double that amount of oxygen? What if I had 6 moles of oxygen? Doesn't it make sense that I could make double the amount of Fe2O3? Absolutely. So I could end up making 4 moles of Fe2O3. What this tells us is that there is a ratio of 3 moles of oxygen to 2 moles of Fe2O3. The important and obvious part of this example is that the coefficients in the balanced equation tell us the mole ratio. That's the most important concept in stoichiometry. Now, let's try 2 more related to the above balanced equation. So let's clear this up just a little bit. We'll go ahead and rebalance this, but we're going to make it so we can read it, I think, a bit better. So we had a 2 here, folks, a 4 here, and a 3 there, didn't we? All right. Now, how many moles of iron would be required to react completely with 6 moles of O2? So this is how we do this problem. We start with what we're given, and we're given 6 moles of O2. So I'm just going to write that down. 6 moles of O2. And we're going to multiply by a line, by a conversion factor. See what I mean? We've done this before, haven't we? And we want to get out of moles of oxygen, so we're going to put those on the bottom. And we want to get into moles of iron. So What numbers do we put there? Do we have a conversion factor that will allow us to go from moles of oxygen to moles of iron? Yeah, we do. Absolutely. It's the coefficients in the balanced equation. Doesn't the balanced equation say for every 3 moles of oxygen, I need 4 moles of iron? So let's use that here. For every 3 moles of oxygen, I consume 4 moles of iron. So now we're out of moles of oxygen, and we will have our answer in moles of iron. So let's just do the math. 6 times 4 is 24, divided by 3 is 8. So I would need 8 moles of iron to react completely with 6 moles of oxygen. Okay, why don't you try the next one on your own? See if you can do it. How many moles of iron and oxygen are needed to produce 8 moles of Fe2O3? So pause the video and try it, and then come back and see how you did. See you in a second. All right, welcome back. So let's begin with what we know. 8 moles of Fe2O3. We'll multiply by a line, and we want to get out of moles of Fe2O3. Let's go ahead and put that on the bottom. And let's get into moles of Fe to begin with, because we need to know amount of Fe and amount of O2. So let's take a look at our balanced equation. Doesn't it say for every 2 Fe2O3s, I need 4 irons? So we can use that as a conversion factor. 2 moles of Fe2O3 need 4 moles of iron. So moles of Fe2O3 are gone, and my answer is 8 times 4 divided by 2. So 8 times 4 is 32, divided by 2 would be 16 moles of iron are needed. Now we're not done, because I also asked about the amount of oxygen that's needed. So let's do it again. This time we'll do it for oxygen. So I want to make 8 moles of Fe2O3, put moles of Fe2O3 on the bottom, and this time we're going to hop into moles of O2. So let's look at our balanced equation again. 2 Fe2O3s need 3 oxygens. So 2 moles of Fe2O3 need 3 moles of oxygen. So moles of Fe2O3 are gone, and my answer is 8 times 3 divided by 2. So 8 times 3 is 24, divided by 2 would be 12 moles of oxygen. Okay, pretty straightforward, isn't it? Now, we're going to add a little twist to this. This time, well, I shouldn't say this time. In the future, I could give you grams instead of moles and ask you for grams of iron or grams of oxygen that are required. And you should be able to convert from moles to grams. So we'll see that in just a little bit. Let's go ahead and try example 2, another sort of easy one, where we're doing mole ratios. Okay, so in example 2, we have 4.83 moles of bromine reacts with excess sodium. How many moles of NaBr will form, according to this equation below? So, do you remember the first thing we do? That's right, we better balance the equation. Stoichiometry is the mathematics of a balanced equation. So let's put a 2 in front of NaBr and a 2 in front of Na, and that balances it. Number 2, we have to convert moles of the given substance into moles of the unknown substance. So that's not too bad. We have 4.83 moles of bromine, and we want to hop out of moles of bromine, so we'll put that on the bottom, folks. And what do we want to get into? Well, we want to find out about NaBr, don't we? So we want to find out about moles of NaBr. So what's my conversion factor there? That's right, the coefficients in the balanced equation. Doesn't this say for every 1 mole of Br2, I can create 2 moles of NaBr? So 1 mole of Br2 can create 2 moles of NaBr. So moles of Br2 are gone, and when I do the math, I will have moles of sodium bromide. So all we have to do is take 4.83 and multiply it by 2, don't we? And we end up with 9.66 moles of NaBr can be produced. Not too bad, is it? Yeah, this is sort of fun, isn't it? All right, now we're going to add a little twist to it here. This time, I'm going to start with grams of something, and I want to find out how many moles of something will be produced. So a little bit of a twist, but I think you guys will follow me on this. It's not too hard. So I have 96 grams of oxygen reacting with carbon monoxide. How many moles of CO2 will be formed? So let's write the equation here. What's reacting? Well, oxygen's reacting with carbon monoxide. And what are we making? Yeah, we're making CO2. How many moles of CO2 will be formed? That's a nice synthesis reaction, just by the way. All right, let's balance that by putting a 2 in front of CO2 and a 2 in front of CO. So that should take care of us. It looks like I have 4 oxygens on both sides and 2 carbons. So we balanced our equation. That's the first thing we had to do. Now remember, stoichiometry is the mathematics of a balanced equation, and the balanced equation gives us a mole ratio. So if I have grams to begin with, I need to convert that to moles so I can use the mole ratio in the balanced equation. So I have 96.0 grams of O2. We're going to multiply by a line. We're going to get rid of grams of O2. Remember, we want to get into moles of O2 so we can find the mole ratio by using the balanced equation. So 1 mole of O2, let's see, each oxygen, this is old school, we've done this a long time ago. Oxygen has an atomic mass of 16 and it's O2, right? So we have 32.00 grams per mole. So 96.0 divided by 32.00 gives us 3.00 moles of O2. All right? Now we can use the mole ratio. Now we can convert the moles of what's given to us into the moles of what we want to find out about. So I have 3 moles of O2, correct? And I want to get out of moles of O2. And I want to get into moles of CO, because the question said how many moles of CO will be formed. Now, how do I get that conversion factor? That's right, from the balanced equation. For every 1 O2, I can produce, I can produce 2 CO2s. So we're going to CO2, not CO, kiddos. So for every 1 O2, there are 2 CO2s that can be produced. So my answer is 3.00 times 2, which is 6.00 moles of CO2 that I can make. Now, this is how we do it using one expression. Start with grams given, 96.0 grams of O2, multiply by a line, get out of grams of O2 and into moles of O2. 1 mole is 32.00 grams, so grams of oxygen are gone. Then we can continue with this, but this time we want to get out of moles of O2 in this step and into moles of CO2. Remember, that's a 1 to 2 ratio, so moles of O2 divide out. So my answer is 96.0 divided by 32.00 times 2, and guess what I get? That's right, 6 moles of CO2 can be produced. Okay? Alright, we're going to continue with this in the next video, so be ready, but in the next video I'm going to ask for grams and I'm going to give you grams, so we're going to have another conversion here. So be ready for that, folks. See you soon. Bye-bye.